Welcome to a new lesson. In this lesson, we'll be discussing and analyzing slope-point form equations. An example of a slope form equation, or a formula, is written right below. I want to help you to understand what all these variables mean. The blue variables are the not changing variables of y and x, while the black variables are the coordinate of a point. Of x1 and y1, while m is the slope of this line. For example, describe the graph of the linear function with this equation. Y equals -2 equal to 1/3 x plus 4. Then we're going to graph the equation. The -2 and the 4 have a specific importance. They're the coordinates of a point on this line. What does this mean? What kind of point is it? Well, the x is the 4. The y is the 2. And we always change the opposite sign of those values. So if x1 is positive 4, really our coordinate is 4. If our y1 is -2, so our coordinate really is for the y2. It's always the opposite sign. The slope of this line is the coefficient in front of the bracket, and the slope is 1/3. So when we're graphing this equation, we know that there's a point of 4 and 2, so 1, 2, 3, 4 to the right and up 2, 4 and 2, and that the slope of this line is 1 1/3. That means for every movement to the right of 3 units, the graph rises by 1 unit. So 1, 2, 3, and 1 movement up. Now we connect these two dots, and here's the equation of our line. Let's take a look at a different example. Given the following graph, write an equation in the slope point form for this line. Then we're going to rewrite the equation in part A in slope-intercept form. And what is the x-intercept of this line? So there are two things to consider in slope point form equations: the slope and a point. We already have 2 points on the line. We could pick one of them, so let's pick the easy ones with the positive values, namely the one on the right-hand top corner. That point has a coordinate of 3, that means 3 movements to the right and 1 movement up. That is the x and y values. What about the slope? Using 2 points, let's find the rise of this graph. 1, 2, 3, 4. The rise is 4. Sorry, the run is 4. While the rise is 1, 2, 3. 3 is the run. Pardon me, the rise again. So slope in this case is equivalent to 3 over 4, which is 3/4. We have a point and we have a slope. We could find the equation in slope point form. Let's rewrite the equation. Y minus y1 is equal to the slope, m, times x minus x1. So how do we put the values in? Well, we know that we always have to take the x-coordinate and the y-coordinates into our equations first. The y-coordinate is 1, So in our equation, we'll put as the value as -1, the opposite sign. The slope is 3/4. And I'm just going to use red for good measure, so it looks better. We stick with the bracket and the x, and now the x coordinate is 3, so we always take the opposite of 3, or positive 3, which is -3. And this is our equation in slope point form. The hardest part awaits us is how do we change this equation into slope-intercept form, slope y-intercept form. Namely, we have to solve for y and have mx plus b. So how do we change this form into this form? There are two methods to do this, and the first method is to expand and to move this basically separate y from anything else. So how do we do this? How do we expand? We have to distribute the 3/4 to the x and to the -3 by multiplying. 3/4 times x is 3x divided by 4. 3 times -3 is 9, -9 over 4, because 3/4 times -3 is -9 over 4. Next part is we have to move the -1 from the left-hand side equation to the right-hand side equation by adding 1 to both sides of the equation. So we have y on the left-hand side, we have 3/4 x minus 9 over 4 plus 1. Now when we're adding fractions, we have to find the lowest common denominator, so we have to, in this case, change 1 to 4 over 4 by multiplying both sides, or numerator and denominator, by 4. So we get 4 over 4, and now we're going to simplify the equation. And -9 plus 4, that's when we add the numerators, it will give us -5 over 4. So this is one way to do the equation. This method requires your knowledge of knowing fractions, knowing how to add and multiply fractions. There's another method to solve this question, and this method is to get rid of fractions and altogether. So let's start from the beginning, how we convert this into a slope-intercept form. So take a look at the 4. That is a fraction. We want to get rid of that 4. The way we get rid of it is by the opposite. If it's division, then we have to multiply. So we're going to multiply both sides by this 4. We can do that because it's an equation. Whatever you do to the left-hand side, we have to do it to the right-hand side. So we multiply both sides by 4. That means the 4 will cancel out. So we have on the right-hand side just 3 times x minus 3. Well, on the left-hand side, we have to distribute the 4 into the brackets. So we'll get 4y, and 4 times -1 is -4. Now we still have to expand on the right-hand side. So we have 4y minus 4 on the left-hand side. On the right-hand side, we have 3x. 3 times x is 3x. 3 times -3 is -9. The next part is that we have to separate the y from all the other numbers. In other words, isolate. The way we do that is that we add 4 to both sides to cancel out the 4's. And on the left-hand side, we get 4y is equal to 3x, and -9 plus 4 is -5. The last thing we have to do is knowing that there is a multiplication sign between 4 and y, we have to divide, do the opposite, by -4 both sides of the equation. If we do that, the 4's will cancel, and we'll have y on the left-hand side. On the right-hand side, we have 3x over 4 and negative 5 over 4. Notice that the answers are exactly the same, but the procedure is a little bit different. So this is the slope-intercept form. The last question has been asked is, what is the y-intercept? Meaning, what is the point right here? What is the y-intercept? We could get this from the slope y-intercept equation quite easily. It is negative 5 over 4. That is the y-intercept. Now let's take a look at an example where we have a little bit of an application. The sum of the angles, s degrees, in a polygon is a linear function of a number of sides n of the polygon. The sum of the angles in a triangle is 180. So we know that when we have 3 sides, we have 180 degrees. The sum of the angles in a quadrilateral or 4-sided figure is 360 degrees. What is the linear equation to represent this function? First, let's put these points, these coordinate points, on the graph. So the horizontal axis is the number of sides of a polygon, and the vertical axis is the angles, the interior sum of the angles. So we have 3 sides, and that's a triangle. So here's our coordinate point for a triangle that has 180. And for a 4-sided figure, we have 360 degrees for our quadrilateral. So here is our other coordinate. And since it's a linear function, we can find the slope of it. There are 2 ways to find the slope in this case. Because we have a graphic representation, we can just find the rise and the run. So the run is 1 unit, while the rise is exactly 180 degrees. So our slope is 180 over 1. A second method to find this slope is to use the slope formula. It is y2 minus y1 over x2 minus x1. In this case, let's use the coordinates to find our values. So here are coordinates rewritten, and we first have to label our coordinates. The 3 is x1, 180 is y1, and the 4 is x2, and the 360 is y2. So we're going to plug in these values once we label them into our slope formula and solve for the slope. And we should get the same thing as earlier. So we have 360 minus 180 over 4 minus 3. And we'll get the same thing. You get 180 over 1. So now we found slope. We have 2 points. We only need 1 to find the equation of this line. Again, we're going to use the point slope formula. So y minus y1 equals m bracket x minus x1. And we're going to plug in one of the points, and I'm just going to pick this one. It doesn't matter which one you choose, as long as it's a line, as long as that point lies on this line. The equation will be a little bit different, apparently, but if you actually expand it and change it to slope y-intercept form, it will be apparent that it's exactly the same equation. So again, don't forget that we'll always take the opposite sign of the y and the x coordinate inside the equation. So now we have minus 180 The slope is 3 minus x, bracket x, and we always take the opposite of 3, which is, in this case, negative 3. And here is your equation. Now we're going to use this equation in part B to determine the sum of the angles in a dodecagon. Well, what is a dodecagon? A dodecagon is a 12-sided figure. That means our value of x, or value of n, is 12. We're going to plug in that value into our equation. So we get 3 times bracket 12 minus 3, which is 12 minus 3 is 9, so it's y minus 180 is equal to 3 times 9 is 27. Then we add 180 to both sides. We found a little mistake. Now recall that the slope of the equation is 180. We found this. The slope is 180, not 3. So we have to make sure that when we're copying our equations that we don't make copying mistakes and copying values. So it's actually 180 x minus 3. That changes our equation just a little bit. So we're still looking for a dodecagon. In this case, the x, or number of sides, is 12. And we still have y minus 180 equals 180 times 9. Lastly, we'll have on the left-hand side y minus 180. 180 times 9 is 1,620. We have to separate or isolate for y. So we add 180 to both sides. And we get, as y is equivalent to 180 degrees for all the sums of the interior angles in a dodecagon. And our last example. Write an equation for the line that passes through a specific point and that is parallel to a specific line. Y equals 2 over 3x minus 5. The word parallel means that the slopes have to be the same or equal slopes. So the first thing, identify what the slope is. It's 2/3. It's always a number multiplied by the x. So the slopes have to be the same, but now we have a point. This means we can rewrite the equation y minus y1 over x, don't forget x1, with the slope that we have and the point. So what's the equation? Y, it's always opposite to the y coordinate. Opposite, that means opposite in sign. So if it's -1 in this case, it has to be +1. The slope is 2/3 because it's parallel to the first line. And x is, well, because it's 1, the coordinate is, right here, is 1. It has to be opposite of 1, +1, which is -1. And this is the line in slope point form for a parallel line to 2/3 x minus 5 and has a point of 1 and -1. For a perpendicular line, in this case, the slopes are not the same. They're negative reciprocal. This means that a perpendicular slope is, well, we interchange the 3 and the 2 and take the opposite sign of the slope. In this case, it's negative. So now our equation will change. The points will not. It's still going to be y plus 1 is equal to x minus 1. But now our slope will be negative 3 over 2. Because this point is perpendicular to 3x minus 5 and has a point of 1 and negative 1. This concludes our lesson.